Hello, my name is Masa Abdelnabi. In this video, I present our computer graphics project. The purpose of this project is to visually demonstrate Newton's third law of motion using a C++ simulation built with the Freeglot library. This law states that whenever an object exerts a force on another object, the second object simultaneously exerts an equal force in the opposite direction. In the simulation, two spheres move horizontally in the opposite direction. Each sphere starts from a different position and moves with the initial velocity. As the animation runs, the spheres approach each other and interact through collisions. When the spheres collide with each other or with the boundaries of the window, their velocities are reversed and slightly increased. This change in the direction and speed represent the reaction force that occurs as a result of the action, making the law easier to understand through visual movement. An additional concept demonstrated in this project is human visual perception at high speeds. When the speed of the motion exceeds a predefined threshold, the program enables merged mode. In this mode, the two moving spheres are visually replaced by a single larger sphere located at the center of the scene. This illustrates how fast-moving objects may appear merged to the human eye due to limitation in visual perceptions. To maintain clarity and simplicity, the interface displays only minimal information. The current speed of one sphere is shown, along with a text indicator that shows whether merged mode is active or inactive. Technically, the project uses a Freeglot to handle window creation, rendering, lighting, animation timing, and perspective adjustment. Core functions are responsible for drawing object, updating motion, detecting collision, and maintaining smooth animation. Overall, this project provides a clear and visual explanation of Newton's third law while also connecting it to perceptual concept, making it both educational and easy to follow.
Hi, my name is Shahid Omar. The title of my project is Action Reaction Ball and is graphical simulation ball in C++ using the FreeGlue library. The goal of this project is to show the Newton's third law of motion. For every action, there is an equal or opposite reaction, and to highlight the idea of version of perception at the high speed. At the beginning, I have two balls placed in the x-axis. The first ball starts from the left side and the second ball starts from the right side. Each ball moves with the initial speed in opposite direction. When they collide with each other or hit the wall, their speeds are reversed or slightly increased. The behavior illustrates Newton's third law in version of interactive way. Additionally, I implemented a phrase called merge mode. When the speed of the ball exceeds a specific threshold, the two balls visually merge into one large ball in the center. This represents how human perception can change at high speed, where objects may appear as a single entity rather than sprint one. From a technical perspective, I use FreeGlue to create the window and handle event, the CMath library for mathematics, impression, and the program is organized into several main functions. Display callback responsible for the drawing the balls and the text on the screen, including the speed and the major mode. Update updates is position of the balls every 16 milliseconds, handle collisions and adjust their speeds. Reshape callback management is presective and viewport when the window is resized. The final result of dynamic simulation where two balls move, collide, and act according to Newton's third law. At high speed, the merge mode activates show one large ball in the center along with inducting the current starts. In conclusion, this project combined physics and visual perception and presentation in Newton's third law in both education and graphical way. It allowed students to see the law not only in theoretical but also as a practical simulation.
My name is Tasneem Abu Daher. In this video, I will explain our project for the computer graphics course. This project aims to show Newton's third law, which states that for every action there is an equal and opposite reaction. Using a graphical simulation written in C++ with the free GLOT library. The idea of the project is based on displaying two balls moving in opposite direction along the horizontal x-axis. Each ball starts from a different position with an initial speed. During the simulation, the balls move toward each other when a collision occurs between the two balls, or when ball hits the window boundaries. The direction of motion is reversed and the speed slightly increases. This behavior clearly shows the concept of action and reaction, where forces are equal in magnitude and opposite in direction. The project also highlights the concept of visual perception at high speeds, when the absolute value of the ball speed exceeds exceeds a predefined threshold called the merge threshold. The program activities merge mode. In merge mode, instead of rendering two separate balls, the program displays one larger ball at the center of the screen. This represents how the human eye may visually merge fast-moving objects into a single object due to perception limitation. To keep the interface simple and focused, only two text elements are displayed on the screen. The first text shows the current speed of the first ball, and the second text indicates whether a merge mode is on or off. From an implementation perspective, the project using free GLUT to create the window, manage rendering, handle timing update, and respond to window resizing. The program relies on function for drawing the balls and text, updating position and speeds, detecting a collision, and maintaining a proper 3D perspective view. In conclusion, the project combined physical simulation and visual perception to present a Newton third law and in a clear and educational way, using a simple interface that help focus on the core concept rather than unnecessary visual complexity.
This code is written in C++ using the free GLOT library. It creates a window and simulates two balls moving on the x-axis. At the top of the code, I define global variables, the initial position of the balls, their speeds, the radius, and the threshold of merged mode. The function drawText is used to display text on the screen. The function display callback clears the screen, setups the camera and lighting, and then draw the balls. If the speed is above of the threshold, it shows one larger ball in the center. Otherwise, it shows two separate balls. It also displays text for the speed and the merged mode status.
The function is colliding balls checks if the two balls are touching. The function updates move the ball every 16 milliseconds. If they collide with each other or with the walls, their speeds are reversed and slightly increased. The function reshape callback adjusts the viewport and perspective when the window is resized.
Finally, the main function initialize free globe, set up the display, reshape and update the function, enable deep testing, and start the main loop. In summary, the code defines variables, update ball position, handles collisions, draw the ball and tags, and manage the windows.